Welcome, everybody. This is the lecture video for Unit 15. So this is does not include a walkthrough of the project components. Those are recorded in separate videos, which I have pre-released. So when I get to kind of the functional tasks in this PowerPoint, I will, talk about them and not actually demonstrate them. And I'll have you refer directly to those videos to do a walkthrough. Part of the reason for that is when I play with some of these AI tools, some of them have like a sign-in process, and I record that into the videos. And then I play with the tools and fumble with them and get them to work, and that's all recorded there. And I don't want to do that during a lecture. So the focus here is predominantly lecture. I do plan to move pretty quickly. There's a ton of slides, by the way, and some of them we'll move through them pretty darn quickly, and you'll see what I mean. All right, so I'm just going to kind of press forward here right away. All right, here's the agenda for this unit. In all three of the project units, so 13, 14, and 15, we looked at one of the major aspects of AI from a project standpoint and some of the key tools that are out there that are being used in the real world to do this, all from a no-code type of perspective. So we're going to look at the no-code tools for computer vision. Computer vision is the last area. The first area we looked at was statistics and data. The second area was natural language processing, which we did last week with the chatbot stuff. And this week we're looking at computer vision, which is identifying images, basically. We'll learn a tool for data labeling, and then we're going to learn a separate tool for modeling computer vision. Both are very, very powerful. Both are accessible for free, by the way, as well. Right. So as I just said, we learned about statistical data, NLP, and now we're focusing on computer vision via no-code tools. When we start using no-code tools for computer vision, we use it basically to do these tasks. So collect the image, curating data, annotating the image, or labeling it basically, or creating a model of the image and then using it for other purposes. So all of those apply. Here's a really quick screenshot, by the way, of a bunch of tools that are out there currently, right, when they created this. And this is back in 2021 when they put the slide together. That back then, so think about this, 4 years ago, basically, all of these tools were already out there that already all did computer vision. So if you're thinking like this, Gen AI stuff just started happening, wrong, right? It's been around for a while, and people have been using these tools for quite a while. We will be focusing on a couple of them that you see listed here. The one that we're going to use is Roboflow, and you see Roboflow is actually listed in a couple different areas here. And then there's also the CVAT software. I'm not even spotting that in here anywhere, but that's the other one that we'll be looking at. Once again, we think about the project cycle whenever we're thinking about these types of projects. And once again, where do you put the no code tools, in the stages of an AI project? And it really can be in a few different stages. The ones that we're going to focus on, once again, are for labeling and modeling information. So for data labeling, the tool, that we're going to look at here in just a second is capable of doing this. But, let's look at it as a concept, right? We can look at a picture like the one that we see on the screen here. And because we've been trained as human beings from a child, right? How do you know that that's a dog? Well, at some point when you were a child, your parents probably said, "Oh, look, the cute little dog. It's a doggy," that kind of thing. And that's how your brain identifies it. But there are salient features of a dog that make it a dog and not a cat, or not a squirrel, or not a bird, or whatever, right? But sometimes, to train a computer model to understand what a dog is kind of like the process of explaining what it is to a child. Like if a child sees a furry animal with 4 legs and a tail, that is friendly and you can pet, what's to say it's not a cat, right? I mean, who's to know? Um, and it says here, data labeling is different for classification and object detection, right? Um, this process that we're about to do is a manual one. We're going to take the images, just like talking to a small child and saying, that's a dog, that's a cat, right? That's the process that we're looking at here. But you notice that, like in the photograph, and they start talking about like bounding boxes, right? And that's where, here we have a whole image, and yeah, that's a dog in that image. But in truth, if we make the box as small and as tight as we can, the smaller and tighter it is, well, that's really the dog. That other stuff in the background is not really part of it, right? And if we could trace around the dog, every little pixel of the image, we could, tell it, what is the dog. So there's practices for doing this, by the way. So the best practices include you label every object of interest in every image, right? Highlight the whole object, right? Like I'm noticing with the cat, maybe part of the tail is cut off. I can't really tell, right? Label the occluded object. So in other words, we've included the object, but there's also the space outside of it. When we do this process, we want to make those boxes tight, and we want to have very specific label names. So I don't want to call the dog a mammal. I want to call it a dog, very specifically. The one tool that they point us to is the CVAT tool, computer vision is the acronym. We will go to this website, and once again, I'm not going to be demonstrating these steps. I've completed these steps in those other videos, but if you do go to this website, the CVAT website, you can actually start using it straight away, right? So you can hit the button there, start using it, or try for free. Either one of those tools will get you in there. Typically, you want to sign in with an account. What I would recommend is a student, right? And this is with intent. Like if you use a private email account, your trial might be more limited. If you use a student account, so in other words, you use your student email account with the .edu at the end of it, that sometimes gives you more access rights to some of these sites. So you can use your Google, right? Because our school accounts are basically Gmail accounts, and then sign in with your school account. That would be my recommendation. If you have a GitHub account, apparently you can do it with that one too. So just be mindful of that. When you do get into the product and you get signed in, you get to this interface, and you'll be asked to create a new task. When you create that, you give it a name, right? And I forget what I named mine. It was something pretty inane. In fact, I could probably bring that up on the screen here. Of course, I mistype it. That's how it goes, folks. And let's just see if I can get signed in here. It should sign me in automatically, I think. And you can see that I have my test project is up on the screen, right? So I did the process of creating a new task. I called it test project one. That was what I thought of at the moment. You could probably be a little bit more meaningful, and try to provide whatever information is required. So add a name, add a label. What are the labels we were going to use? Well, they're using dog and cat, so I felt compelled to follow that pattern. The other thing that I did is, as you start to add labels here, right, you'll type in the label name. And I did find that interface a little quirky, real frankly. Like I typed it and then I had to like delete it, and I'm like, it didn't stick. Oh wait, it did stick. And you'll see that in the video. I had a little bit of fumbling with it. So type in dog, then type in cat, and then it creates these little boxes, and those are the labels. And I didn't do squirrels, I didn't do rabbits, etc. Then it's asking you to upload images. So real frankly, what I did is I just went to Google, right? And I searched images, right? And so like it went to that, and then I just searched dog and cat like that. And I came up with a whole bunch of them. And so what I did is I just found some that I thought would be easy to classify. Um, and I just did a right click, save image as. That was my process, right? And then I don't know how many I grabbed, like a dozen of them or something like that. So you should do the same. Save them, like you want to put them in your downloads folder, you want to put them all together in a folder. But then once you have those files, you can drag them into this interface down here at the bottom and then hit submit when you're done. Next, they want you to click the task menu because now you got to start like labeling stuff. So you go here, you open it, right? And then you'll see that it has this like job here at the bottom. So you click on the job number and then your images will pop up. And then one at a time, you can use the toolbar on the side here to create a shape around the animals. Now, the images they're using is kind of an interesting one, right? Because I can kind of see the entirety of the cat, but not really the entirety of the dog, right? But you notice how we as humans very easily can identify which is which, right? The fact that we would have to train software to do it is kind of weird, right? So you use the shape tool, and then you basically click and drag, and the objective is to try to fit the entirety of the animal within the frame. So like they're finding like this corner is a pretty good spot, so they would like kind of like click and drag around it. Now I'm not actually using the tool. I'm going to just use my goofy annotation tools here, right? But kind of like doing something like this, right? With a much smaller line, you know, dog, for example, right? And that box is highly exaggerated in size and everything, but this is just to give you the idea, right? So click and drag and create that bounding box around the dog, right? Click, drag, release is the maneuver, right? If you've never done that before. I always take it for granted that people do it all the time, but you know what? Some people don't. So that's the case. So that's the dog, right? And then I go ahead and I highlight the cat, make another. So even though they're in the same image, it's two different things that we're labeling, right? And all the images that I found in Google were the same way, had both a dog and a cat in the image. And then, you know, for example, if you did have other animals or other types of objects, you could highlight those and say, hey, dog, cat, bird, fish, car, you know, hammer, whatever. And then you would have to have labels for them. Once you have it highlighted like that, then you hit the save button, right? And then once you've done that for all of your images, and this part was a little weird for me, and maybe I can get into the interface and show you it, like here. Because you do have this like navigation tool. So if you have more than one image, like I did, you can use this to kind of go through the images. And you can see I didn't have like great images. Some of them are pretty blurry. Some of the bounding boxes overlap, right? I found that one kind of challenging. And notice I didn't know if I should do the whole animal or like what I just did the head, you know, etc. Right? And I just wanted to show you that aspect of it. After you've saved it, you can then do what we call exporting the data set. And what that ends up doing is it puts it into a data format that can be read by other pieces of software and then used to extract the meaning from the image. So when we're creating those bounding boxes, what are we really doing? We're setting the parameters within that image where that object can be found, and that's just data, right? It's like an XY coordinate going from like this point down to that point. That's a dog. There's another XY coordinate from here to down here. That's a cat, and it's relative to the image. They have you choose a format you want to use, right? They're just using CVAT for images. Give it a name, say okay, right? And then when you're all done, it creates what we call an XML file, right? Now, you guys are not web programmers, right? But this is like a technology I teach to my web students. XML is the universal markup language, right? And ML stands for markup language, by the way. X denotes that it's generic, and it's very, very similar to HTML that we use to create web pages, right? And basically, the features of that language are basically that you have an XML declaration, and then you have what we call tags. Tags are inside of greater than and less than brackets. Every tag that you open, like file name, is closed with the same name and a preceding slash. And so data becomes what we call encapsulated. Right? This is where, terminology, whatever. But this is sort of similar to like a JSON file, the key value pair that we use in like Python or CSV files, because we have the tags which describe the information, and then the information in between the tags that is the information. So like, for example, database would be a key, unknown would be the value. But in this case, we are basically pulling in a particular image. The image has a size, and then we have objects within the image. One's named a dog, and it tells you the XY coordinates of the dog, right? And it does so tangibly as data. So this is just to kind of explain the XML file. But all the XML file is really doing is showing all the bounding boxes and what's labeled what. So the dog exists in that photograph in this XY coordinate system. The cat exists here in that system. All right. And the XML files, by the way, it's just another one of those data transmission formats where the data and the meaning of the data is transmitted with the file, right? So it's a very common mechanism. XML files are very, very often used to feed information into computer programs or databases or spreadsheets, by the way. So go through the process of labeling, find a bunch of images, put them into that interface, draw boxes around them, and label them. All right, it's not really that hard to do. When you're all done, export. They're asking for the Pascal VOC format, whatever. It'll still be an XML file, by the way. And then we have a little bit of a discussion with it. Can I ask any of the people that already did this, did you run into any problems doing this? Did you find this easy or hard? Go ahead, Laura.
I'm sorry. The problem that I was having was with the images. I actually figured it out in the last class. I was trying to figure it out. It kept saying network error every time I would upload the images of the cats and dogs because I was following along with the
Okay.
video. And it was saying certain images, like I had two images of two different German shepherds, and for some reason it wasn't reading those. So I just deleted them and picked different pictures, and then it was able to continue to the next step.
Okay. And see, that's one of the tricks is like when you find the images online, the assumption is that you have your own images, right? So like, let's say you're working in a factory and you're manufacturing a widget, and you have like pictures of all the different widgets, and you can train, based on those photographs, that you have your own photographs. But like I did, as I went out to Google and found some random pictures of dogs and cats, I didn't like use my own pictures of dogs and cats because I really don't have a lot where they're together in the photograph like this. I do have both dogs and cats, but whatever. John?
Yeah, I was going to ask you, what is the end result, the end format that we need to deliver this in? Is it capturing the steps like we did for, I think it was 13? No, wait, 13.
Yeah, I mean, the,
No,
the way I have
anyways,
it,
or do we capture the export? I think they have an export feature, I think.
yeah, and I had this kind of split up, right? Like do the PowerPoints, And then the slides here for CVAT. Your final version should be labeling fruit, right? You should be doing fruit, but if you did dogs and cats, whatever. Screenshots are part of it, but if you've exported the file, some of the people that did this one also gave me the file that was exported so I could look at it. If you just looked at the file and screen captured it, I was okay with that. I just wanted to see that you actually created it, so that it's working, basically. Any other comments on this one?
Sorry, and I wanted to bring to your attention that the data set, in some, at least one or two directories, they're empty. So I found the link to the original somewhere on your notes, or I found it in all the different artifacts that we have available. And I went ahead and downloaded that, and that's how I compare. And I noticed there's about, I don't know, 600 of them missing. That's what I wanted to
think. If you click on the title here, oh yeah, you're right. The data set is not there. All right, you know what? I can rectify that, but apparently people were finding it maybe the same way that you did. Or did I? Oh no, I had it right here. Right, this is for the second exercise that we haven't reached yet. All right, you know what? We'll come back to that, John.
That's fine. Sure.
All right, so I'm gonna move on here with the PowerPointy thing. And did we come out of slideshow mode? No, there we are. All right. All right. So the second aspect was looking at modeling, right? So the modeling is a little bit different than labeling. Labeling, if you guys aren't picking up, is a mechanical process that can be done by humans, right? And often the initial training of any computer vision system is doing that. Like, once again, I use the example of a small child. How do you teach a kid what is a dog? What is a cat? Well, you find a dog or a cat and you point it out to them. Or you have a book with a picture and you point it out to them. You label it for them. Now, the difference with modeling is, right, it's kind of the same process in a sense, but it's being used to classify things. And the point is to have it be autonomous and to recognize these things on its own, right? Not to have somebody else label it for them. And then when you give it a random image, it can look at that image and make its own determination with the data that you trained it with, and then base it on that training data and then tell you what it is. Like, it will predict what it is, and hopefully accurately. Now, the one tool that we're pushing here is Roboflow. And Roboflow is, once again, one of these free online tools. And yeah, there are paid versions of it too that are really super powerful, but the free ones are actually pretty darn powerful themselves. And I think, compared to some of the tools that I've tried, this is one of the easier ones to use, which is why they're kind of demonstrating it here. All right, let's go ahead and kind of move forward. The other aspect of this that's really cool is you can kind of leverage it from the free version into the paid version. And a lot of people are using tools such as this. If it's not this one, the ones that are similar that are also web-based to do some of this work. And the why is the automatic computer vision tools here that you're training with requires a lot of computing power and storage and processing and memory. And these guys are doing it all out in the cloud, and it works a whole lot faster than you trying to do it on your system. Not that it's not doable on your own system, by the way. So they're giving us a use case scenario here, which I think is kind of helpful. So let's say you're a quality control supervisor at this company. You manufacture steel plates. Due to the pandemic, your team is hit with quarantines. You're unable to cope with the heavy workload with insufficient labor. This is a problem that a lot of manufacturers are having, by the way. A lot of people don't want to go to work, or they won't show up, or whatever, You're looking at ways to automate the quality checking process, right? So going through the whole project cycle again, right? you go through this whole thing. And let's look at the first thing. What is the actual problem? Like, can we figure out what that is? And what keywords can you find? So what they're saying is that we're kind of already given that, right? So we're kind of like going back to the slide that we were just looking at, but we want to automate the quality checking process because we're shorthanded, right? The pandemic happened, we're shorthanded. So we problem scope this, and we will notice the highlights here, right? We're going to automate the quality checking process. That's the thing that we're trying to solve, basically, and that's how we're going to do it. Are there ethical issues? If it can automatically detect defects, I don't see that there's any ethics problem here, right? The only question is, like, are we putting somebody out of work in the process? That's possible. But if you're already like shorthanded, probably not, right? Here's the other thing. Would the machine or the software or whatever visioning tools we're using, can it do a better job than the human? Can it work 24/7? Does it take sick days, et cetera? So, that's kind of the scenario though there. Right, then you check to see what data do you have. Is there anything wrong with the data ethically? No, I would say. All right, so now you need to start collecting the data. What is the data in this case? And this is where this area is different. The data is the images that we're looking at. The image is the data, right? However that's captured. So how are you capturing that? Well, if you're doing this like in a factory, you probably have your own imaging systems. You have your own cameras, and then maybe you have images of products the way they're supposed to look, if they're correct. And then maybe you have images of products that, okay, well, that one's broken. You see, look, it's broken, that kind of thing, where it wasn't quite made right or whatever the thing is. No ethical problems there because the stuff that we're making is proprietary. We're manufacturing it. We're not stealing it from somebody. All right. Okay, so if you need images as your data, where are you getting that from? And one thing that they're asking here is, can you source the data image online? So, okay, dogs and cats, pretty darn generic. Fruits, pretty darn generic. I can find images of that stuff online. But if I'm manufacturing a very specific product that nobody else makes, the only source for the image is me taking the images, right? You take them internally. So that's kind of a thing. All right. So you do have to start with labeled data. This is so if you're going to train a model, you have to have something to start with to show it in order to say, okay, these are correct, these are incorrect, right? Like you're telling the child that's a dog, that's a cat. Correct, incorrect, right? And then you look at the images. Are the bounding boxes good? Are they labeled correctly? Is there something that looks like another thing? Whatever it happens to be, you got to go through this and provide all these answers to these questions here. Right? Do we have models that we can use? So here's the interesting thing about this product. It can do a bunch of this kind of stuff automatically. So it can classify and do object detection. It can segment in an instance, or it can do semantic segmentation. And all of this stuff can work inside this product. And this is one of the reasons that the product is so darn powerful. How do we measure the performance? We basically train it, and then we give it sample images and see how well it does. And the hope is that it very accurately identifies, based upon its training, images that it's never seen before. And then you need to make the determination, is that accurate enough? Right? So that's kind of, the aspect of it. How do you implement this? Well, okay, so from a practical standpoint, you get some cameras out on your factory floor, right? And put them at key spots in the production line. It says fixing a camera on the quality control area. Camera takes an image of the steel surface, Image is sent to a computer within the network. The computer will perform the prediction, and then it will tell us if it's correct or not. So then we go into Roboflow. So this is the process that you use on Roboflow. So you got to set up an account, you import your images. This is the data set that is provided in this unit. So that is a zip file that contains all the images that we train Roboflow with. Perform the model training, and you don't use all the data. You use a good portion of it, but not all of it. And then you evaluate it by taking some of the data that you didn't give it, send it in, and you know what it's classified as, and then see if it picks it up correctly. That would be the process. So as we were doing with the CVAT software, Roboflow has a website you can go to. So you go to it, you get started, right? And after you get started, you do get an account. And I've noticed that they like now email me every day ever since I signed up, by the way, because they really want me to buy the product, you know. All right. They suggest that you continue with email, but if I would suggest, since we're on a Gmail system, once again, use your school account, go through the Google thing. Go with the free plan, right? We don't want you to pay. I want you to notice how much it costs per month, right? It's not an inexpensive tool. Yeah, $249 a month. Woo, yeah, right. But if it's helping your work, right? Yeah, okay, and it's saving you money, then it's worth it. But I want you to notice here that you get like how much access is provided. So you can only use public data, 3 training credits, and 10,000 API calls. And if you do more than that, then you got to get over here. Now, when I signed up as an educator, and I'm throwing this out there, Roboflow said, oh, you're an educator. You probably need more training credits. So we're going to give you free training credits because you're an educator. You guys won't get that, by the way. Right? That's kind of the thinking. So don't like keep training it. Save those credits, by the way, because we might need them for the machine learning class. I'm just saying, right? Either that or we make new email accounts and sign up with a new email. Right? Whatever. It's the workaround. All right. So once you're in there into the interface, you create a new project. And the one that we want to work on is object detection. But you will notice that when you go in there, they have other things that you can do too, right? Classification, instance segmentation, right? Like they can, like for example, pick out the bad part of the orange instead of the good part, you know, that kind of thing. Key point detection, where you see kind of like a tracing around of an image like that. But this is the one that we're focusing on. We just wanted to look at things and go, oh, it's an orange. Very nice. Okay. Name everything. Here they're making us select classification, and notice the settings that they're using. And then we do our import. Now, the data set is provided in the unit. That is a zip file. And if you go through the process of even just looking at that zip file, and I'm just going to kind of go here and just kind of point this out. And I guess I didn't download it here. So I must have it in my downloads folder. That's pretty lame on my part, but I just kind of wanted to show you the data. Okay, I'm not finding it easy. Maybe it's on my desktop. I really don't know. But if you open that up and take a look, and you can see I'm not finding it easily, so I'm just kind of giving up here. But if you open up the zip file and take a look inside of it, it's really just folders full of images, and those folders have subcategories that go with it. Now I just remembered where I can find it. All right, this is kind of goofy, so I apologize for all the fumbling here. Let's go ahead and open up a file folder, and I think I have it in my regular AI folders. Probably here, right? Okay, so these are the data set images right here, right? And if you open it up, you know, and you just pick a spot, right? Like These are the kind of images that we're looking at. What they are, I have no idea. Yeah. What is this? Who knows? The people in the factory know what this is. We don't know what it is. You see what I'm saying, right? So this means nothing to us, but to the people in the factory, this is meaningful. And so they have all this information, in the form of images that they captured from their line. You will take that folder and drag the whole thing, unzip it and drag the whole thing in there. And then it will read all those files. So if you have a lot of files, it's going to take a little while, both to upload it and to process it. So just be aware of that. They're showing you the process of it here, right? Like where to find it. Click save and continue. And then they ask you this question, and you guys remember this from like kind of the early parts of the class, like how much data do you use to train and how much do you use for testing, right? And here they're basically choosing 70% for training in this situation. And I don't know if that's the number that we stick with here, but it goes through the process of uploading. After the upload, you get this interface, and you pretty much go with some of the basics on here. So like if you need to add other steps, like, and this will be very dependent on the kind of images you have, the quality of the images, et cetera, what choices you make here. So I'm just kind of putting that out there. They show some of the settings that they use, which are some of the defaults, by the way. You can imagine that if your image is super high res, it might take longer. If it's super low res, it might not be good enough, all of that. But once you have all that information in there, the images are uploaded, your settings are set, then you can click create. And then what happens is it will take some time. I forget how long it took mine. I'm going to like guess a half hour or something like that, if I remember right, when I first ran it to do all the training on it. And this is on their servers, mind you, like after the images are uploaded. And I'm sure they've seen this data set before, that kind of thing. And then it does the modeling aspect. So now we go into the training piece with the modeling. So you click the train button, hit that thing, and this is where it takes a while. So this one, look, you can see, well, 29 minutes. That is about what it took mine to operate. This message did not come up right away, though. It was like after 5 minutes it came up. So maybe it was more like 35 minutes or 40 minutes, something to that effect. When you're all done, you get a screen that kind of looks like this. And then I want you to notice too that they do give you an email when the training is done, and then they give you basically some code, which includes an API key. So the API key becomes important because now you can use that API key to use those machine learning models in a program you're writing, right? So maybe you're writing a program for an industrial robot that recognizes a bad piece of whatever and then takes it and throws it into the waste bin instead of into the box for shipping, that kind of thing. So once you have trained it, then you can do the evaluation part, which is to take the rest of the data they didn't use for training and then feed it back into the system to see if it correctly identifies something. So they do give you some of these tools here, right? And I just want to be really clear on this. When I look at this screen, and you'll see this in the video, I'm like, oh my God, it wants me to pay it. I'm not going to pay. That was like my first reaction. And then I realized, oh, they kind of show you what it looks like. And this is a screenshot of what it's going to look like after it runs. And it might not be the actual data, but that, the point is that you go through the process. If you need, and you guys are going to start to recognize what these things are now, right? We have the confusion matrix. It's like kind of like a true false chart kind of thing. And then we have basically a vector analysis that looks a lot like a scatter plot, right? And these are visualizations that are pretty typical that show you basically how well the model's performing ultimately. So they have you then click on training graphs, right? And then you get these results, like how much is lost, how much is accurate, and everything here they measured in epochs, and that means like how many, I think, thousands of transactions it goes through or something like that. And so to evaluate the model and see if it's truly working, then you click the visualize model button here, and then we take a random image and feed it in, and then we see if it can identify it correctly, predict the right part. And you'll notice here that when you click on it, it's over here in the side panel where you actually see the result. You can see it says predictions, and I want you to notice the key value pairs, like a Python dictionary or a JSON file. Notice that format, very common for data. And it's predicting, it's from the welding line, it's got an ID, and its confidence level is 92.9% that it's whatever it's identifying it as, a welding line, right? So it's seeing this as a line of weld material or something. Now what you can do is you can go into their data set, and this is why I wanted to pull up the data set in the first place, because when you're looking at it, and I think I closed it, there's different folders, and the folders are named with what's inside of it. So if I grab something out of the punching hole folder and feed that image into the model, then it should, in principle, accurately identify that it's a punching hole, right? And once again, take a look at the confidence. The confidence on this is not so high. It's only 62%. The one that we saw previously was like 93%, much more confident. So are we sure that this is a punching hole? Well, we're 62% sure. Not 100, right? Could be a non-punching hole. I'm not really sure what type of holes there are. All right. Now, the other examples that they have here, right, is they have these code sample things, which allow you basically to download code snippets with the API keys and then feed them into your other applications. So if you're writing a Python program, or you're writing a web page, or you're creating an app or something like that, and you want to integrate this information into your app, they give you the code to start with. They want you to do the web thing, right? And then it gives you the code, and this looks like it's just JavaScript here, that what we're seeing. But if you can get it to the point where it's creating your code files for you, well, then we can take this stuff, like this is code, basically backend code for a web page, and that code creates this web page, right? And then all I have to do is add that web page code to my website, and I can put this on a live website. And that kind of blew me away, that they give you this and it's pre-writing the code for you, and it looks pretty nice too. Yeah, very, very cool, no doubt. So once you have that interface up and running, you should be able to upload an image into this interface, and then that will make the prediction. And then I want you to notice, oops, and I went too far too fast, that I drop an image in, and then it gives you the predictions down here of what it is and isn't. And I want you to notice that it's 90% sure it's a punching hole. It's 3% sure it might be a welding line or a rolled pit or a crescent cap, with really low percentages, but really what it's saying is it's a punching hole, right? But it's not excluding the other possibilities in reality. It is actually including those. You can export this, by the way, and so they have these deploy options. So like you can look at all the different things. Now, this is probably pretty meaningless to you unless you're an app developer, a website developer, or whatever. But if you were a Python coder, for example, you probably would get Python code, right? And so you can grab some of that code if you wish, and you can turn that into with your project. Not really a concern at this point to leverage that code, but if you were doing higher level stuff, and now you have a tool that you can train to do computer vision, you didn't have to buy the software, you just have to pay that subscription fee, maybe you just pay it for a month, train a model, and then move on. Right? So think of the possibilities there. But if it's something you're doing all the time, that might be a very small monthly cost for what you're getting here in terms of the power of the tool. Now, where this kind of all ties back in and brings us full circle is we just learned the CVAT tool. We just learned RoboFlow, right? And once again, I have separate videos on actually doing the processes that we were just talking about. So watch those to do the project. But now we start talking about this. This is where we start to use generative AI to help us in the process of training models. And we talked about this in principle, but here's an example, right? If I wanted to train a model to identify zebras, you know what? It's very unlikely that I'm going to have a lot of pictures of zebras sitting around. And even if I go up to the local zoo, they probably have like 3 zebras and I took like 5 pictures and that's about all I got, right? Or I go out to the internet and I find a bunch of pictures, great. But you know what? There's a ton of horses out there. What if I just took horses and then had asked generative AI to paint some stripes on them? And that's really kind of what makes a zebra different than a horse? I mean, there's probably more than just the stripes. It might be the shape of the ears or the tail or, whatever. But generally, a zebra is a horse with stripes, And so what they're really talking about here is that you can use like these GAN, networks basically to take images that are known, superimpose the features that make it something else, and basically create synthetic images for training your tools. And that's become a real big thing now as well. Because the more images you have, the better training that you can do. Now, here's kind of an interesting thing. We talked about this when we talked about GANs last time, is having basically a discriminator network. So in other words, like we generate this false image, we feed it into the AI looks at it and goes, oh, that's a false image. Because zebras don't look like that, it's not dogs with stripes, it's horses with stripes, whatever, right? But the fact that it can basically identify a false image, even though it's creating the false image. So then it trains itself to create images that are better, right? So it doesn't trick itself into thinking it's a false image, right? So that remember that whole conversation that we had. And we have this other problem too, like images get complex. Like, for example, these are apples. Well, I can't take apples and convert them to oranges because they have different shapes and textures, right? So I can't take apples and just paint them orange and call them an orange. Now we just have orange apples, right? Or I can't take an orange and convert it into an apple. I give it apple coloring, but it's really got the shape of an orange. That doesn't work either, right? So these are the kind of things that go in your head. Now, there are tools out there, right? And one that they're pointing out is called runwayML, right? Runway machine learning, that can take an image that you currently have and based on a prompt, change it to an image that you don't have. So for example, right, next slide. What if you have an image here, and this is a drawn image, right, of the sun and a beautiful sky and a couple of clouds. This is daytime. And then you're like, all right, can you take that image and turn it into night? And there are tools out there that would do that. And here's how it works, right? It identifies the sun. The sun's kind of anomalous, right? So the sun, first of all, the sun's not out at night, but maybe it's just about to set. I don't know, right? You notice how the sky is now dark. The clouds are now kind of like, a different color, right? But the sky's not blue. And so that's kind of like the example of what those tools can do for us. Can I ask a question? How many of you, and I'm sure I know a lot of people do this stuff, like like you see some social media thing. It's like, click here to generate the cartoon image of yourself, or the one I've been seeing a lot lately is where people create their own action figure with accessories. You guys have seen those, and I'm like, okay, that's really cheesy. But some of them, I see them for some people, and it makes me laugh because I know the person and I'm like, that's pretty spot on, all of it. But have any of you guys ever played with that stuff? Has anybody ever created AI images of themselves? Anybody here tried that? I got a couple of X's, thumbs up, right? How about let me ask you this. Okay, so that one's not it's not uncommon to create AI images of yourself. And you know what? There's a lot of AI tools that can do that, including ChatGPT and Gemini and Copilot all do it. There's some that we learned earlier that are specifically designed to do it, but even the big AI engines can do it. And they will do a better job of it if you can describe yourself better. But has anybody ever used Gen AI to generate video? How about that for a weird one? Oh yeah. Yeah, I would okay, so Susan, you've done that. Or are you just humoring me here?
No, I've done it just for, fun. It's pretty interesting because to me, it looks like something that you would like dream because, it doesn't go into place, but it's pretty fun.
Yeah. There are engines that do that. We once had, and this is maybe a year or two ago already, somebody in our, I think, construction sciences area made an AI generated video of characters learning how to build freeways, right? Because that was what they were teaching. So he had a whole video and he was showing it off to everybody, going, "Hey, I made this with AI. You guys are jealous, right?" And it was really cool looking. It really was because he took a lot of time prompting it and reprompting it till he got it was like maybe a 5-minute video, but in the end, it really showed all the main points he was trying to prove, right? Um, and it had artificially created characters that were part of the video. It was pretty cool, right? Um, this stuff is going to start happening more and more now because these tools are now ending up in the hands of common people like us, right? It's not like somebody at Pixar or Disney or pick one of those like big movie houses where they like, for example, show a picture of a scene in the city and they do like a flyby and you don't even realize that none of it's real, right? They take a picture of I don't know, New York City and they superimpose some AI people on it. And then, and they don't have to pay actors. They don't have to fly cameras out to the situation. The quality is really high, so you can't even tell it's generated, right? Unless you're looking. No, I see you got a question.
Not so much a question, but on the Gen AI, I just keep doing this thing and it will not work. Because it's only ever been shown pictures of water falling with gravity. So if you ask a Gen AI to produce something where the water is actually flowing upwards, it can't because it's never conceived it or seen it before. No matter how many times you reprompt it, it does not get it. There's weird things like that. Like
Well,
gravity's built into AI.
well, you maybe part of your prompt needs to be to tell it to ignore gravity.
Yeah, actually, I haven't tried that one actually.
Imagine yourself on a planet where the gravity is backwards. Draw me
Yeah, I'll have to
over.
try something goofy like that.
Well, yeah, right. I mean, it's kind of goofy even to say it. Um, yeah, I mean, there are okay, and see, these are kind of the weird points that are on my slide right now, right? That you're asking AI to build things, but it has to understand the context under which it's building it in order to actually build it. When I went through some training this past fall, and I know I've probably shared this with you guys, but Microsoft came to our campus and they were teaching us how to use Copilot to generate images, for example. And what we learned from the process is I can go to Copilot and just say, "Hey, make me an image of whatever," or what I can do is I can realize, okay, well that was all right, but it's not really what I wanted. What would it take to make that image what I wanted? So what I had to do is I had to keep feeding it information, and it took like 6 or 7 or 8 prompts before I got the image to actually generate what I was really looking for. So that's what I thought pretty fascinating. Yeah, and you guys can read these bullet points for yourself, but that's kind of the point of what we're talking about. Here's, for example, look at the first bullet here, real-time illustration. It says, imagine describing a sunset scene over the water and then watching the generative AI model create a captivating video that perfectly captures the scene's beauty and spirit. So maybe before you create a video, first you create that right image and then tell it, turn this into a video, right? These are kind of interesting. Now, when you start playing with some of these different tools, and I will tell you, some tools use the same AI models in the background, so you don't get a lot of difference. Others use their own engines and have like different kinds of training. I've also seen some demonstrations recently where people are creating music on the fly with AI, and how some of those music AI engines work really well, and some of them are kind of like, they're just creating the same song over and over. And what I would recommend, if you guys are really interested in doing this stuff, is experiment. Take some time and experiment. I've been experimenting mostly with stuff that relates to my work. It's like I'm tempted to try to create AI music, but I have a guitar in my lap and I can just I can create real music right here. So that's kind of my thinking, guys. I would never use AI to do that, but maybe I should. Maybe I could use AI to create a backing band so I could play over it. Why not? Right? Yeah, there are people that do that stuff. All right. So the tool that they are recommending is runwayML. So you can see video to video generation, image to video generation, and text to video generation. And it is the last one that I'm probably more intrigued by. If you want to try that tool, by the way, just go to their, look them up, and I guess I can bring up a browser here, and let's just go to runwayML. Right, and and I don't think it takes much to do it, but you can see that the video snippets that they're putting up on screen here, right, that you guys are seeing, these are all AI generated videos. Yeah, right. And so even if they're kind of goofy, whatever, the fact that you can even create it, I mean, I don't have to go out and shoot it or drop it in a video editing program. I can think of all these crazy things now that are possible. Like if I can, tell it, hey, generate footage of, a forest fire, right? And there it is. And I can use that as a background for something else or whatever. I'm not going to try that during class here, but I would encourage you guys to do that. What I do want to do here is I do want to take a break. We're at 9:02 right now. Let's take about a 5-minute break. Okay, 9:03. Come back at 9:08, and then we will switch to the other unit. All right, folks. I'll see you in 5. This video ends here, by the way.